Welcome everyone and welcome to Chapter 5. In this chapter, we are going to understand real MCP execution from start to finish in a way that is practical enough to run live and clear enough to teach confidently. When I say real MCP, I mean this very specifically. The client and the server communicate through MCP protocol lifecycle calls. We are not doing direct Python imports from client into business functions and calling them locally like a helper script. Instead, we are doing protocol-based interaction. Initialize, discover tools, call tools, and receive structured outputs. MCP stands for Model Context Protocol. It standardizes how AI clients discover and call external tools. Without MCP, every integration becomes custom and fragile. You hard-code interfaces, couple orchestrator logic with implementation logic, and then portability becomes difficult. With MCP, you get a clean contract. The client asks what tools are available, selects one, sends structured inputs, and processes structured outputs. That is why MCP is not just a library choice. It is an architectural contract that improves portability and reuse. Now let's anchor this to architecture before we run anything. There are 4 layers in the mental model. Layer 1 is the AI client, which decides intent and orchestration. Layer 2 is transport, such as STDIO or HTTP, which carries protocol messages. Layer 3 is the MCP server, which registers tools and executes handlers. Layer 4 is external systems, such as APIs, files, knowledge bases, or databases. The core architecture benefit is separation of concerns. The client stays orchestration-focused, while implementation and integration logic live server-side. Now we map this to Chapter 5. Chapter 5 implements one MCP lifecycle in 2 modes. Mode 1 is local MCP over STDIO. Mode 2 is remote MCP over HTTP. The lifecycle is identical in both cases. Only the deployment boundary and transport differ. Now I will teach this as 2 complete tutorials, each with commands, expected output, and function-level meaning. Keep in mind that this time we will not ask customer to enter the message, but we have given hard-coded input to accept pre-declared customer message. For local MCP with STDIO, we have declared the message in scripts/test_mcp_tools.py. Inside, main open parenthesis colon message equals I paid yesterday, but my account is still not activated. This is frustrating. For remote MCP, we have the message declared inside the test_remote_mcp.py. Tutorial 1. Local MCP over STDIO. Please open terminal in root folder first. Run this command, pip install -r requirements.txt. This installs all required dependencies, including MCP and OpenAI SDK. Create or verify.env in root folder. We already have this file, so add the key and the model name for embeddings. In this chapter, RAG fallback has been removed, so a valid OpenAI key is mandatory for local semantic retrieval. You can create your OpenAI API account and generate the key. Now move to chapter folder. Run Python scripts/test_mcp_tools.py. Let's discuss what should happen so you can interpret output correctly. Expected local output explanation. First, you should see a discovered tools list, typically including rag_search, lead_score, and escalation_check. Next, you should see a knowledge base result payload with top match documents. Then you should see a lead score payload with a numeric score. Finally, you should see an escalation payload showing should_escalate and reason. If you see those three structured result blocks, local MCP flow is working correctly and protocol-driven orchestration is validated. Now let's explain the local code path clearly, file by file and function by function. Start with scripts/test_mcp_tools.py. Function_extract_text. Open parenthesis result, close parenthesis. This function is a response normalizer for display. MCP tool responses can contain structured content blocks, so this helper extracts text content safely and returns a clean printable string. Function_extract_JSON open parenthesis result close parenthesis. This function converts the text response into JSON when possible. It allows downstream logic, such as reading lead score numerically, instead of relying on string parsing. Function main parents. This is the local client orchestrator. It builds Stadio server parameters so the client knows how to launch the local MCP server module. It opens stdio transport streams between client and server process. It creates client session, calls initialize, then list _tools for runtime tool discovery. It calls rag_search with customer message. It calls lead_score and passes return score. It calls escalation_check with message and score. Then it prints all outputs in a classroom-friendly way. Now server layer. AgentDesk_AI/MCP_server.py. Global MCP equals fast MCP open parenthesis quote AgentDesk-tools quote close parenthesis. This constructs the MCP server instance and registers a tool namespace. Function rag_search open parenthesis customer_message str close parenthesis. This is the MCP exposed retrieval tool entry point. At high level, it delegates to business retrieval wrapper and returns structured retrieval response. Function lead_score open parenthesis customer_message str close parenthesis. This is the MCP exposed lead scoring entry point. It delegates to scoring logic and returns structured lead score output. Function escalation_check open parenthesis customer_message str lead_score_value:int close parenthesis. This is the MCP exposed escalation decision entry point. It delegates to escalation policy logic and returns decision with explanation. Runtime MCP.run parents. This starts the server loop and listens for MCP protocol calls from clients. Now business logic layer. AgentDesk_AI/tools.py. Function search_knowledge_base open parenthesis customer_message close parenthesis. This wraps semantic retrieval for tool output formatting. It calls the RAG module and returns a predictable structured payload. Function score_lead open parenthesis customer_message close parenthesis. This performs deterministic lead intent scoring. It checks business-related and buying-related signals and returns bounded lead score. Function decide_escalation open parenthesis customer_message lead_score close parenthesis. This applies rule-based escalation logic. It checks urgency and sensitivity indicators, combines with lead score threshold, and returns should_escalate and reason. Now semantic retrieval layer. AgentDesk_AI/rag.py. Function load knowledge base parents. Loads chapter KB documents from local JSON data source. Function_embed_texts open parenthesis texts close parenthesis. Calls OpenAI embeddings API and returns vector representations. Function cosine similarity open parenthesis vec_vec_b close parenthesis. Computes semantic similarity between vectors using normalized dot-product logic. Function_load_kb_vectors open parenthesis docs close parenthesis embeds KB corpus and caches vectors in memory for efficiency across calls. Function simple _rag _search, open parenthesis, query comma, top _ k equals 2, close parenthesis. This is the retrieval orchestrator. It loads documents, embeds query, loads or prepares KB vectors, computes similarity, ranks, and returns top K matches. That completes local tutorial and output interpretation. Now tutorial 2, remote MCP over HTTP, open terminal 1 in chapter folder. If default port is busy, use a free port like 3010. Run $env port equals 3010. Run npx-y at model context protocol /server-everything streamable HTTP because it hosts the remote MCP endpoint. Now open terminal 2 in chapter folder. Run Python scripts /test _remote _mcp.py http://127.0.0.1:3010/mcp. See the remote URL printed by client. You should see a remote tool list printed, usually including tools like Echo. If Echo exists, you should see. Now, let's define expected remote output clearly. Expected remote output explanation, you should see the remote URL printed by client. You should see a remote tool list printed, usually including tools like Echo. If Echo exists, you should see Echo result text returned successfully. If these outputs appear, remote MCP lifecycle is working correctly. Now function level explanation for remote client file scripts /test _remote _mcp.py function _extract _text open parenthesis result close parenthesis. Just like local helper, this makes MCP content readable for terminal output. Function main parents. This is remote orchestration entry point. It resolves remote endpoint from CLI argument or environment value. It opens streamable HTTP transport. It creates session and performs initialize handshake. It lists tools from remote server. It calls Echo when available. Then it prints results for verification. Now, connect both tutorials conceptually. Local and remote are not different MCP paradigms. They are the same protocol lifecycle executed across different transport boundaries. In local mode, transport is STDIO and server is sub-process on same machine. In remote mode, transport is HTTP and server is network service. Now full chapter takeaway in teaching language. Chapter 5 demonstrates that protocol semantics remain stable even when deployment model changes. The client always orchestrates initialize, discover, invoke, and pass phases. The server always owns tool registration and execution. The business layer always owns decision logic. The RAG layer always owns semantic retrieval mechanics. Transport can change from STDIO to HTTP without rewriting orchestration logic. In this session, we saw how MCP enables real-time agents to reliably use many external systems like knowledge bases, CRMs, ticketing, payments, and APIs through one standard protocol instead of hard-coded integrations, which improves scalability, architecture quality, maintainability, and portability across local STDIO and remote HTTP deployments. We also covered the full MCP lifecycle and the role of each Chapter 5 file and function in production-style orchestration. And next, we move to LLM-driven orchestration, where the model decides when to call tools, how to combine outputs, and how to generate robust context-aware responses.